Hey, Cecilia, how is everything going?
I'm using my smartphone to do research.
About what?
I am thinking about the behavior study on the visual attention of phone users. It would be very interesting given the time that people spend on their phones. We need an eye tracker for the mobile platform. Can we buy a pair of eye tracking glasses or a mobile testing platform?
No. We need to use the off-the-shelf equipment, such as the frontal camera on your phone, so that the large-scale, in-situ data can be measurable and comparable.
Using the frontal camera alone? Professor, we can estimate through the reflection of the screen. If the gaze point moves in zigzag along the screen corners, the screen reflection on the cornea will move inversely to the relative location of the iris. In other words, the gaze movement can be measured by the vector pointing from the iris center to the centroid of the reflection.
But how would this method be affected by factors like lighting and face-to-screen distance?
You're right. Let me check. Wait a minute, Professor. We've studied the size of the reflection in different illumination conditions and common smartphone use postures, including sitting by a table, sitting on a chair, slouching, sitting on the floor, prone, supine, standing, and walking. It looks very promising, and here are some demos.
In this demonstration, a user was looking at the images one by one. The gaze model was calibrated by the fixations on the corners of the screen in two positions. Our method works well with different phone holding postures. Here is a demo of browsing. The red rectangle indicates the upcoming user interactions. After fixating on the arrow, the user clicked it to collapse the content. During typing, we can see that the gaze led the key presses. Our estimation may not be accurate enough to identify a key with a single gaze point, but with the help of typing gestures and the special design of keyboard, it's full of potential. Also, it looks promising for the identification of image objects. There can be numerous possible applications based on ScreenGlint. Interestingly, from this demo, we can see that some users can touch type even on a virtual keyboard. More importantly, our method shows a great potential for visual attention analysis. We can tell which link is likely to be selected. Some reading behavior can also be observed, such as the time spent on a heading and the number of lines that the user had read and skipped. Based on this technique, we could even see the speed decrease of a saccadic movement after a typing error. For more details of our technique and its in-depth evaluation, please look at our paper. Thank you.